Suppose a family has 3 dogs and 2 cats, and we want to write the ratio of dogs to cats. Now this is kind of a trivial example just to show the idea of how we illustrate ratio. So we want to write the ratio of dogs to cats. Now there are 3 dogs and 2 cats, and it's just the ratio of 3 to 2. And we can write that ratio in several ways. We can write it as a fraction, 3 to 2, like this. That's the ratio of 3 to 2. Or we can write it using a colon like this, 3 to 2. Or we could say 3 to 2 using the word 2. And if we want to write the ratio of cats to dogs, then since there are 2 cats and 3 dogs, it would be the ratio of 2 to 3. You see, and that's all there is to it. There's nothing mystical about which one is on top and bottom. It actually flows from the idea of the words. This is the top number, and then the one that follows the 2 is the bottom number when we're talking about the fraction method. So it's cats to dogs would be 2 to 3, and in colon form or using the colon it would be 2 to 3 like this, or 2 to 3 using the word 2. If we want to write the ratio of dogs to pets, since there are 5 total pets, the numbers involved would be the number of dogs associated with the number of pets. Number of dogs is 3, the total number of pets is 5, so it would be 3 to 5. So 3 to 5, or 3 to 5 like this, or 3 to 5 written like this. Now, the important thing here is the nature of the setup of the numbers here to illustrate the ratio. Actually, I mentioned that this is a trivial example, and really it's not quite accurate either mathematically, because ratios technically need to have the same units. And when we're talking about cats and dogs, the unit would be cats and dogs, you see. So we'd have to say 3 dogs to 2 cats or something like that in the ratio. Well, usually the unit situation takes care of itself. If we say, what is the ratio of 6 feet to 8 feet, then it is the ratio of 6 feet to 8 feet like this. Now I'm writing the unit for emphasis here, or the units for emphasis. And I want to show you that we can do without this unit. Usually we write ratios without units involved, and we can think of these feet units canceling in a sense, just like factors would in numerator and denominator. So this is the ratio of 6 to 8, which can be reduced. 6 to 8, 6/8, you know, is 3/4. So this is the ratio of 3 to 4, or the ratio is 3/4. Now, notice the cancellation, just as we have with fractions, we could go through a cancellation even using this decimal idea. The colon idea. If we have 6 to 8 like this, then we could say, we could treat this as though it were parts of a fraction and say, let's reduce this. Let's reduce this form. Well, 2 into 6 is 3, 2 into 8 is 4, so we could write this as 3 to 4 like that. Suppose we want to write the ratio of 16 miles to 2 miles. Now we have to be a little careful with this, but 16 miles to 2 miles, now we're dealing with the same unit of measure here, so we can just write 16 to 2 like this. You see, and we reduce to 8 over 1. Now, usually, and let me emphasize that, 8 over 1, because 2 into 16 is 8, 2 into 2 goes 1. Now, normally we would write 8 divided by 1 as simply 8, but to emphasize the idea of ratio here, we might leave it in this form, 8 to 1, or write it as 8 to 1 like this, or as 8 to 1 using the colon. Now here's a situation involving different units of measure. We're not going to face this situation in this section, but you might be curious about what would have to happen if we did have a situation where the units were different. Now, so we're kind of restricting our discussion to the illustration of ratio when the units are exactly the same. But if the units are not the same, then here's what has to happen. If we're trying to write the ratio of 2 feet to 2 yards, then we could say that this is 2 feet to 2 yards. Now, notice that, that if we didn't write this, the units involved here, that we would have 2 to 2. You see, and that wouldn't quite be accurate, would it? Because after all, 2 feet is a lot shorter distance than 2 yards is. But we can turn this into a true ratio if we write the same unit of measure in numerator and denominator. Now, it's a little easier to change the yards into feet than it is the feet into yards. So let's do that. We could write this as 2 feet to, well, let's see, every yard has 3 feet. 3 times 2, 2 yards then would be 6 feet. You see, so really this is the ratio of 2 feet to 6 feet, and we can think of it as 2 over 6, or 1/3 as the ratio. Suppose we have a map, and the map illustrates the position of home, and suppose there is a city called Alto, which is 10 miles away, and from Alto to another city called Saxville, it's 8 miles. We want to represent the ratio of the distance between home and Alto to the total distance traveled if we're traveling from home to Saxville. Now, this seems complicated, but and that's the reason I want to show this example. Because all we're doing is writing a fraction, and we're just identifying the numerator and denominator of a particular fraction. And to do that, you know, it's when we talk about setting up ratio numbers, the ratio of A to B means A is in the numerator and B is in the denominator. So A to B, numerator to denominator. So all we need to do is identify those aspects of this problem. Now, here's what I'm talking about. We've got ratio of, now it's something to something else. It is blah, 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 blah to blah, 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 blah. So it's the ratio of whatever all of this means to whatever all of this means. You see, and that's how you want to kind of separate it in your thinking. So it's the ratio of, let's see, the distance between home and Alto, that's the numerator of the fraction, and that numerator is 10 miles. It's just 10 here. We're talking about the same unit, so we're not going to worry about the units here. 2. Okay, now we're going to describe the denominator of the ratio fraction. The total distance traveled. Well, we're traveling from home to Saxville. That total distance is 10 miles and 8 miles. Oh, that's 18 miles. So this is the ratio of 10 to 18. You see, like this. And we can reduce, let's see, 2 into 10 goes 5. 2 into 18 goes 9. So it's the ratio of 5 to 9. And we know that we could write this in a couple of other ways as well.